Hello everyone, it's the Prophet Michael David, aka Aries, and this is the second video we're going to do today on the Collatz conjecture. Alright, format again, just like the last video, that is the video you should watch before you watch the rest of this video. It's the Veritasium video on the 3x plus 1 conjecture. It's very, very good. So again, from format from last video, that's the folder that I'm basically going to show you guys and how I would explain this to anybody else. And if you watch the video, you can see that like I'll go after any white whale. That's what I do. So the first thing I did was like I did it backwards, wind conditions, everything. But the second one condition is if you have to pick an odd number, then pick any odd number and what does it become. And as you can see, all those numbers are on the 4 mod 6 line, which means it's a prime problem because it's a mod 6 problem. Remember, I showed you this exact mod screenshot before in the twin prime conjecture, and I've used it a lot of times. But this is how I see prime numbers. So if you have all these numbers that have to land on 4 mod 6, then it's a mod 6 problem. So I did a mod 6 analysis, and it shows that there are only 9 different combinations because you split all the evens up into the 2 mod 6, 4 mod 6, 6 mod 6, all the odds into the 1 mod 6, 3 mod 6, 5 mod 6. All the odds have to turn into evens, but sometimes the evens turn into odds, sometimes they turn into evens, but there's only 9 interactions. There's not an infinite amount of interactions. It's 6 lines that have 9 interactions. And if you spreadsheet them out, that's what they look like. But the better way, as I've shown you before, is to show like a flow diagram. And here's what it looks like. So that algorithm is the solution to the Collatz conjecture. You got to do some logic on some of it, but it shows all infinite numbers are on that sheet. I don't know what mod line that infinity has, all of them, none of them, but I do know that all numbers up to infinity have to fall on a mod 6 line. And that shows that ultimately the Collatz conjecture is not a relationship between numbers, but it's the relationship between lines. And those lines are the mod 6 lines. So now I'm going to show you how to develop a spreadsheet that plays the Collatz game that you can verify this algorithm or that this algorithm will never violate the game, vice versa. Okay, so those two screenshots are the left and right screenshot of all the columns and rows that I have in this spreadsheet, again, Apple's numbers, that plays the Collatz game. And now I will show you the equations for almost all the columns so that you can create your own Collatz game spreadsheet, again, to test out the algorithm. Okay, before we do the programming real quick, those two screenshots, the reason I picked 27 is 27 is an infamous number. If you watch the Veritasium video, it asks, why is 26 so simple, but 27 is 111 steps and goes up so high and everything. And that is because 27 has 31 in its sequence and 31 is a Mersenne prime. We can just go into this later, but So the first one is an analysis of how everyone does it, the hailstone numbers, and the second screenshot is how number 27 looks like in my mod 6 analysis. Again, starting remedial, you're just making an input box, and then on the first one, it's just taking that original input. There's really no formula to it. You're using the dollar sign save column save row just so you make sure that you're always taking that input. Okay, the game column, where it's actually playing the Collatz game. It's not that hard. You're just using a floor function and an if statement. I described a similar thing in the last video, and I'm not going to go into it now. But if you use that equation, that game column, you know, will use the value from above it, except for the first value, and it will play the Collatz game. So if you program it just like that, it will work. All right, odd or even column, using a similar technique just to display whether the number is odd or even. All right, next six are tedious, but we'll try to do them as quickly as possible. And these are just mod 6 line checks. So the first one is one mod 6 line check. And again, the equations, -1 divided by 6 for one mod 6. And you can see the equations for the other mod lines. So now to find the mod line that the number in the Collatz sequence is always on, we're going to take from that information and we're going to make this big equation to pull which mod line it's on and display it. And that's this equation right here for the mod line equation, mod line column. And then this one's remedial, but the steps thing, it's just basically saying it looks at the thing. If the number is anything but one, then it just does the steps. And if it's one, it says end the game. And finally, as like an add on homework, the probably end of game in 3 mod 6, only 3 mod 6. You guys should be able to figure that on your own from what I've given you. The only 3 mod 6 is easy, but the probably end of game, if you guys figure that out, I will be very impressed. Very impressed. So again, this is all in proving the actual algorithm. And while if you look at the algorithm, all there are loops in there, but they all decrease if they're over one, except for the 421, which we can talk about later. But there's only one quasi loop that can go to infinity, and that's if the numbers bounce back from 4 mod 6 to 5 mod 6 to 4 mod 6 to 5 mod 6 to 4 mod 6 to 5 mod 6 over and over. And so again, look at the algorithm one more time, and then I'll show you why that can't happen. Okay, so that second screenshot is a spreadsheet I came up with to show why that the Collatz game can never go divergent because it's algebraic. The left side is a binary analysis, and the right side with the generation stuff is related to it, but that's the generation of long chains. I'm going to break it down into two different screenshots and try to explain the relationship. Okay, so binary 101. All numbers can be turned into binary. That's turned into zeros and one. That's base 2. All right, so if the number, your binary number, no matter how long, ends in a 1, it's odd. If it ends in a 0, then it's even. And all even numbers are some odd number multiplied by 2 a certain amount of times. So if you have a number that ends with 1, it has 1 0 after it, you know it's an odd number multiplied by 2 once. If it has 2 zeros after it, you know it's multiplied by 2 twice, multiplied by 4. Again, 3 is 8. And that's how binary works. So if you know a number has 5 zeros at the end of it, then you can divide it by 2 5 times. And in that way, you can sieve out all the numbers that aren't 3x plus 1 being divided by 2 only once, because you're only looking for numbers that have 1 0 after the 1. So that's all I'm doing here. Finding all the numbers that can only be divided by 2 once before it becomes odd, and then the next generation do the same thing. Generation 2 has to, or generation 1, and the way I put it in there, has to be just half of all the numbers that the X numbers were. Then generation 2 are half of all the first generations were. And that's how you build these long chains where all they do is they can start from any odd number, whether it be from the 1 mod 6, 3 mod 6, or 5 mod 6 number. But as soon as you 3x plus 1 them, they go to the 4 mod 6. And then for an extended amount of time, they bounce back between 4 mod 6, 5 mod 6, 4 mod 6, 5 mod 6, 4 mod 6, 5 mod 6. And the question is, can they ever go divergent? Is there ever a number that can go to infinity? And the answer is wrong, because no, the answer is no, because as you can see, all of the chains have an algebraic relationship to each other. So once again, as you can see in there, the numbers, if they could go divergent, they would have to go from 4 mod 6 to 5 mod 6 over and 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 over, and never interact with any of the other mod lines, which won't happen because there's an algebraic relationship between the starts, the seed number, and the end of those chains, which seem to go divergent for X amount of time. And the relationship for the start of the chains is 2x plus 1, and the relationships for the end of the chain is 3x plus 2. So finally, getting to the end here, that screenshot shows the difference between the numbers in the 2x plus 1 column as related to the 3x plus 2, and how they very quickly get separate or become very long, or the difference is very big. And all the gold ones are Mersenne primes, which goes into our next video. You know, they are part of the longest chains for a reason, and you know, they can be represented as 2 to the n minus 1 is something. Well, that n is the amount of times that they're a seed number that they will go divergent. And so for the first Mersenne primes, that, you know, 2 to the n is pretty small, but it gets very, very large for large Mersenne primes, and you can imagine what happens. All right, for the most part, that's the end of this Collatz video. And, you know, like, even if you didn't totally understand everything, a so-called professional mathematician should. And at the end, I segued about how the Collatz conjecture is related to Mersenne primes, which it's related to prime or perfect numbers, which is the next video. And I solved that one too. But all in all, I think the 2 videos today went pretty well. And hopefully my talks with the mathematicians will go pretty well tomorrow. So again, rule number 1, do not touch each other without another person's consent, aka do not hurt each other. And rule number 2, honesty, it's all about honesty. Lies are a tick down, aka try not to lie. I love you all very much, and I'll talk to you later.